Hello, hi. You are welcome to our class for today. In this video, we'll be looking at dimensional units, dimension of physical quantities. That's what we'll be looking at in this particular video. But before we continue, please, if you have not subscribed to this channel, this is Noble Mind Science Tutors Online. So please click on the subscribe button and the notification button so that whenever we upload a new video, YouTube will notify you that a new video has been uploaded into Noble Mind Science Tutors Online. So my name is Michael, and you are welcome to our class for today. So as I said, today we'll be looking at dimension of physical quantities. Remember that in our previous video, we talked about fundamental and derived quantities and fundamental and derived units. So what we'll be looking at today is the dimensional aspect of the physical quantities. That's what we're going to be looking at today. So please, as I've always encouraged, get your writing materials so that as we are going along, you can be taking down your notes and then follow all the instructions that are given. Then at the end of this video, we'll start to give you some homework or like seat work or assignments that you will need to respond to. And if you look at this particular video, down it you will have a link that will take you to our WhatsApp page. Please, I want you to submit your assignment in that WhatsApp page. Please don't shy away from them, because right from this particular topic we'll start solving some problems, then we'll be giving you assignment to test your understanding. So please ensure that you take those assignments seriously. It is for you to groom yourself, groom yourself so that you become good in the subject area. As I've said before, physics is mostly mathematics, so you have to try as much as possible to upskill yourself in mathematics, and you can only do that by solving more problems. The more problems you solve, the more you get used to the manipulations and everything about physics and the calculations. So right away, we're looking at dimensional quantities. So dimension of a physical quantity is relationship between that physical quantity and the fundamental quantities. We talk about fundamental quantities in our previous video, and we said that those are basic quantities of measurement. So when you are looking at the dimensional aspect of them, each of those fundamental quantities, they have their units and they have their symbols. So you use the symbols, the capital letter of the fundamental quantity, you use it as a symbol for the dimensional aspect of it. So like for mass, the symbol for mass is capital M and the unit is kg. The symbol for length is capital L, the unit is meter. The symbol for time is capital T, the unit is small s. Symbol for temperature is the Kelvin and is capital K. Electric current is I, the symbol is A. So these dimensional symbols, these symbols that are here, they are called dimensional symbols, and these are what you use to calculate or derive your dimensional units. Dimensional units, you also get them the way you used to calculate or derive your derived units. Derived units, you get them from a combination of fundamental units. It's almost the same thing like deriving dimensional units, but this time they are not called derived units, they are called dimensional units. That is how they are called. So right away we go and start deriving some dimensional units or some quantities. we'll start to derive the dimensional units of some quantities. So we are going straight to derivation of some dimensional units of some quantities. Derive the dimensional units of the following physical quantities. Okay, like for volume, we know that volume is given as volume is equal to meters cube, right? It's meters cube, that is meters times meters times meters. And we have said previously that the meters is represented by L. So volume will be L times L times L. So that will now give you L raised to power 3. L raised to power 3. So this is the dimensional unit for volume. Dimensional unit for volume is L raised to power 3. That is the dimensional unit for volume. I hope this one is very simple. I think this should be the simplest one, right? This one should be the simplest one. Okay, so we'll do another one. Let's see. Okay, so this is speed. Dimensional unit for speed. Speed, we know speed is equals to, speed is given by distance S, distance all over time. That is speed. So distance, you know, is measured in meters. Distance is measured in meters, and time is measured in seconds. So I will know that meters, the dimensional symbol for meter is L. So which means speed will now be L over T, because we said the dimensional symbol for time is capital T. So this will now be the dimensional unit of speed, L over T, or you can also write it as this, L raised to power this. So this is the dimensional unit for speed. I hope this one is also easy and it's also simple too. This is dimensional unit for speed. So we'll also take another one so that we'll see different variation. Okay, this velocity. Velocity is V. Velocity V is given as displacement, just like almost like speed too, but this time you're talking about displacement, right? Okay, so displacement all over time. That is velocity, displacement all over time. And we know that displacement is also measured in meters, just like these two. So you have meters over seconds, meters over seconds. So that will also give you the same thing with speed, as this over L over T, and that gives you the same unit that you have with speed. So velocity and speed, they actually have the same units, the same dimensional unit. Okay, so this is velocity, the same dimensional unit for speed. Alright, this one is also simple. I hope you can understand this and follow through. Okay, so let's look at acceleration. Acceleration E is giving us change in velocity all over time. Change in velocity all over time. So from the above, you already know velocity. Velocity is already here, so you can see this velocity. So just put your velocity there. So you have that. Okay, you have your velocity L over T all over T. Okay, so by the time you work this out, you have your acceleration to be L t raised to power 2 minus 2. So this is the dimensional unit for acceleration. This is dimensional unit for acceleration. So this is just how you combine the units together to get your dimensional unit for each of the physical quantities. So we can also do the one for force. Force is giving us, force is mass times acceleration. Okay, so if you bring the dimensional symbol for mass, it's capital M, and then the unit for acceleration is this. Dimensional unit of acceleration is this. It's L times t raised to power minus 2. L times t raised to power minus 2. So this is the dimensional unit for force. Yes, L times M, capital M, L t raised to power minus 2. When you bring the dimensional unit of mass and that of acceleration, and acceleration is this. Okay, so this one is also simple too. Then we can still do the one for momentum. The one for momentum, momentum is giving us mass times velocity. Mass times velocity. That's momentum. So this one, the dimensional unit of mass is capital M. This capital M. So then you bring times velocity. This is velocity, right? That is velocity. So that gives you the dimensional unit for momentum. So you multiply the M by this. So you have the dimensional unit for momentum to be capital M t minus 1. Okay, so this will be the dimensional unit for momentum. This. Okay, so that is how you combine the fundamental quantities to get your dimensional units for each of the quantities. Momentum is given by Newton meter, that is force times distance, Newton meters. So this one is also simple, Newton meters. So this is the unit for force, capital M, L t raised to power minus 2. This is the unit for force, and then that is Newton. And then meter is length, that's capital L. So you bring that in here. I have meter L t raised to power minus 2 times L, which is the dimensional unit for length, meters. So by the time you work this out, you have this. You have meters L squared, capital L raised to power 2, then t raised to power minus 2. So this gives you the dimensional unit of moments. So with this, you can combine the different dimensional symbols and get your dimensional unit for each of the physical quantities that you are looking for. So that is it. You can always get your dimensional unit. So I'll give you the summary of what I've done so that you can put that as your note. I hope this one is simple and this one is easy. So please make sure that the assignment that we follow, you do it. Click on the link below and it will take you to our WhatsApp page where you can drop your answers. I will look at all the answers that comes in, and if anyone that is not correct, I will comment on them. The ones that are correct, I will also comment on them, so that you have a better grasp of. Then you can also check past questions, right? Check some past questions. This is a summary of what I've just discussed, so you can take this down as your own notes for your personal revision. Um, we'll also look at some areas where dimensional units are also important. You can use it to verify a particular equation to see if the equation is actually correct. We've already derived the equation, the unit for assuming you are looking at an equation of this form. This is the first equation of motion. V is equals to U plus AT. To verify that this equation is correct, you can actually use dimensional unit to verify it. From our previous discussion, we see that velocity is L times t raised to power minus 1. So, and this is velocity, this final velocity, this initial velocity, this acceleration, and this is time. So by the time you bring in this dimensional unit into this particular equation, this is what you will have. Because this is velocity, and these two, acceleration and time, will also give you the same units. So you find that this equation has been verified, that since the units are the same on the left and at the right hand side, this equation is verified to be correct. So this is how you can also use the dimensional unit analysis to verify an equation that yes, the equation of physical quantity is correct. So this is your test equation for your understanding. This is your test page for your own understanding. Test your understanding. So please work this out. Put your answers. Click on the WhatsApp link below in this particular video to take you to the WhatsApp chat page. From there, drop your answers. I will look at all of them and then comment on all of them. So thank you so much for your time and for listening. Please, if you have not subscribed or if you are a new visitor to this channel, please click on the notification button, click on the subscribe button, and if you like the video and you want more of this video, please give us a thumbs up, and then also you can put your comments down below. Any comments you make, we'll look at all of them too. Click on the notification button, click on the bell that is ringing. Whenever we have a new video, YouTube will notify you. So thank you so much for your time. We hope to see you in our next video.